Let's proceed to digital and analog data transmission. So we have two types of data transmission. The first one is analog signal. So transmitted power varies over a contiguous range. What are example here? We have sound, light, and radio waves. And we have here digital signal. It refers to the sequence of voltage pulses represented in binary form. What is binary form? That could be zeros or it could be 1. So computer-generated data signal is digital, whereas telephone lines, it will carry analog signals. Take note of the two types of data transmission. So when digital data is to be sent over to an analog facility, digital signals must be converted into an analog form. So conversion of digital signal to analog form is known as modulation. And the term demodulation refers to the conversion of analog signal to digital form. So digital transmission of data is transferred over analog transmission of data due to lower costs, higher transmission speeds, and lower error rates. Thus, images are the differences between analog and digital signals. Have a look at this, the analog signal. So the wavelengths will vary from the heights depending on the voltage that will be transferred, while digital signal, the height of the wave is fixed into 1 or 0. Let's proceed to the modulation techniques in transferring the data. We have amplitude modulation here. In AM, two binary values, 0 or 1 of a digital data are represented by two different amplitudes of the carrier signal. So here, frequency and the phase will be kept constant. In frequency modulation or FM, there will be two binary values of digital data represented by two different frequencies, while the amplitude and the phase are kept constant. In the phase modulation, two binary values of digital data are represented by shift in phase of the carrier signal. So you need to define the following terms: what is an amplitude, what is a frequency, and what is a phase. Okay, put it in your summary notes. I will give you also an assignment regarding these three modulation techniques. Kindly search in the internet and draw the example of AM. And you need to draw also the example of frequency modulation. And lastly, you need to draw the example of phase modulation. Let's proceed. In data communication, there is a device known as modem, which is the short for modulated or demodulator. So this device is used for conversion of digital data to analog form, that is modulation. If we are going to convert analog data into digital data, this is what we call demodulation. So essential piece of hardware were two digital devices want to communicate over an analog transmission channel. So that will be passed through the telephone line. The diagram in our presentation will tell you the importance of a modem in data communication. Assuming that there is a sender who will send a voice message to the other side, and the voice will be transmitted by the computer into zeros and ones, because computer can understand only binary form. So the zeros and ones converted by the computer, it will pass through the modem, and the data will be transmitted into analog signals, and it will pass through the telephone line. Then the other side, there is also a modem. This demodulator will convert the analog into zeros and ones so that it will be going through the receiver's computer. So that's the importance of modem in data communication. What are the factors for modem selection? You need to select, or you need to see the transmission speed. You need to check the external versus external like capacity. You need to see the facsimile facility. You need to check the error correction and data compression. Next topic is all about data transmission services. Data transmission service providers are known as common carriers. So we have here three types of service offered by the data transmission service providers. First one is dial-up line. It operates in a manner similar to a telephone line. Okay? And we have list line, how it operates, a special condition telephone line that directly and permanently connects two computers. And we have ISDN, or known as Integrated Service Digital Network. It refers to a telephone system that provides digital, not analog. Okay, so this is a digital telephone and data service. And we have also value-added network. It provides value-added data transmission service and value-added over and above the standard service of common carriers may include email, data encryption, decryption. We have access to commercial databases and code of conversion for communication between computers. So next topic is all about multiplexing techniques. So what is this multiplexing all about? It is a method of dividing physical channel into many logical channels so that the number of independent signals may be simultaneously be transmitted. And we have here a term multiplexer. It refers to electronic device that performs multiplexing. So multiplexing enables a single transmission medium to concurrently transmit data between several transmitters and receivers. So here is a diagram how a multiplex system works. So we have the two basic methods of multiplexing. We have frequency division multiplexing, known as FDM. So here in this type of multiplexing, available bandwidth of physical medium is divided into several smaller disjoint logical bandwidths. And each component bandwidth is used as a separate communication line. While time division multiplexing, or TDM, here total time available in a channel is divided among several users, and each user of the channel is allotted a time slice during which he or she may transmit a message. Take note of this. There is what you call time slice in time division multiplexing. So here in this diagram about frequency division multiplexing, have a look at this. All of the bandwidths will be separated with some disjoint logical bandwidths, but all of them will pass through into single channel. And at the other end, so the disjoint bandwidths will be separated according to the recipients of the signal. And you will see here how time division multiplexing. Take note, I told you there's what you call time slice. The signal will be sliced into different time frame, and it will be sent at the same thing, piece by piece. They will going to be transmitted in one channel also, and the other end, the multiplexer, we're going to construct or reassemble all the signals going to the receiver. Our next topic is all about asynchronous and synchronous transmission. And let's discuss this one by one. There are two modes of data transmission on a communication line. So when we say asynchronous transmission, sender can send data at any convenient time and the receiver will accept it. And data is transmitted character by character at irregular intervals. and it is well suited to many keyboard type terminals. When we say synchronous transmission, sender and receiver must synchronize with each other to get ready for data transmission before it takes place. So the entire blocks of characters are framed and transmitted together. And this type of transmission will be suited to remote communication between a computer and such device as buffer terminals and printers. So this is a diagram of asynchronous transmission. So there will be irregular time intervals between two characters. And this is what we call synchronous transmissions diagram. And you will see here an indefinite time interval between two blocks of data. And you will see here a block of characters may consist of hundreds of characters. Then we will see trailer containing end of block indication, and there will be a header containing synchronizing the other information.